speaker is Mike Jordan. He's the Vice President of the Enterprise Asset Management Business Practice here at Utopia. Mr. Jordan is a professional engineer with more than 30 years of experience in systems engineering and program management associated with automation systems in asset-intensive industries. Through extensive engagements with industry-leading engineering, procurement, and construction companies, as well as plant owner-operators. Mr. Jordan has developed an interesting perspective on the challenges faced in asset lifecycle information management. And now I'm going to hand it over to your speaker, Mike Jordan.
Hi, folks. This is Mike. I appreciate your time today. We'll spend a few minutes talking about the business problems that are faced by owner-operators doing capital project information handover, and then jump into how standards have evolved to help with that, and what's really been developed as best practices over time. Then we'll spend a bit of time following talking about technologies from SAP and the SAP community that are beginning to address some of these business problems. If we look at the capital project business process as it traditionally occurs, the front-end engineering design activities can take up to 2 years on large capital projects, then followed by some fast-track construction processes that have really evolved over the years to optimize the time to first oil or first gas or first power for large capital projects. During that concurrent engineering and construction phase, the detailed design, procurement, construction, and even completions are done in parallel. As a result, you get thousands and tens of thousands of iterations of changes during that intensive process. And as a result, over time, the owner-operators have taken a position that rather than deal with all of those changes, they'll take handover at the very last moment. Once a lot of those changes are complete, jokingly, sort of jokingly, depicted as just a dump truck handover just before the start of commissioning. This is standard practice. It's what's going on really to avoid that degree of change, and as a result, by starting so late in the EAM build-out process, it's quite often the case that the build-out of the EAM system, that collection, validation, enrichment, transformation, and loading of data, making the transformation from engineering hierarchy to operations and maintenance hierarchy, will go on for 1 to 3 years after start of the plant. As a result of that late ramp up of the EAM system, the EAM operational readiness is only ramps up slowly as you build out the operating systems, and companies quite often will do startup with inaccurate, incomplete data in the EAM environment, and they operate the plant with specialists. So they'll bring in the gray hairs that they trust to be able to run the plant in spite of imperfect operating conditions. And some analysts will say that the design production of capacity of a new plant only ramps up so fast as a result of these inefficiencies. And as you look at it, that stands to reason. If you don't have optimized inspection plans, bills of materials and spares on hand, you don't get optimized plant operations. So design production capacity ramps up slower than optimum as a result. Some analysts, in fact, ARC Advisory Group in particular, has done quite a bit of surveys and analysis in this space, and ARC says that poorly managed information handover can have up to 1% additional total impact. So the total cost of a capital project can increase 1% just because of inaccurate, incomplete capital project information handover. Where you see those impacts are reduced asset availability. If you don't have optimized maintenance plans, inspection plans. If you don't have the right spare parts and procedures, you get reduced asset availability. You get extended startup costs in the form of extra staff, in the form of excess MRO supply chain costs. You get increased environmental health and safety risks and increased maintenance costs. So these are the imperfections that we see in the capital project handover process today. It's been quantified by some other organizations. The NIST survey some time ago with the cost analysis of inaccurate inoperability in U.S. capital facilities has been referenced in this case. NIST did quite an extensive survey, and one of the insights that NIST came to is the cost by stakeholder phase. So as you look at who really pays the cost of inaccurate, incomplete asset master data and interoperability among the systems, it's really the owner-operators. So as we well know, the big gap between the Capex and Opex organization is reflected here. So you have a Capex organization that's measured on the ability to bring a new capital facility online, on budget, on time, and they'll do that in a very efficient fashion. They will have the system commissioned and documented and bulletproof, but the deployment of the operating systems, the capital project information handover and full up build out of the EAM environment is quite often not on the list of objectives of the Capex organization. But the lack of that work done during capital project handover, when Capex transitions to Opex, it's the Opex guys, it's the owner-operators that feel the pain over time from that inaccurate, incomplete asset master data. Fortunately, the standards organizations have come to bear, and over time, we can identify PISL, the European Process Industry organization, has done some excellent work in process industry data handover guide, and followed by FIATEC and NIST with Capital Facility Information Handover Guide. So these organizations, you know FIATEC from things like ISO 15926, have developed a framework for a holistic information handover approach that really recommends the creation of strategies, a facility lifecycle information strategy, and a project information handover plan. We'll spend just a few minutes talking about how these plans work, how they hang together. It really breaks down the process into four primary activities: establish the information handover strategy, determine the requirements, and then create the project-specific handover plan and execute. So in broad strokes, the facility lifecycle information strategy is where you work to get it all right. That strategy looks at the business requirements and decisions and processes in order to get the right information necessary for information handover. And one of the things that's made this an enduring document or approach is it takes the information in bite-sized chunks. The NIST study recommends that you break the information into information packages. So you're not dealing first by saying, I have a dump truck of information, what do I do with all of it? Just the opposite. You go to the to the end user and say, what is most important, what is critical, what is needed, and then build the strategy based upon the end result. If this is what I need, then you build the information package to work back upstream to say, if I do nothing else, let's get the process down to deal with that particular information package. The result is you're not dealing with a dump truck of information. It's a pool-based strategy. So you start with the business user and say, through all of this, what is it exactly that you need? Define the most important information package, and then build the value proposition that says, here is the value of getting that information right, and you build a business case for the work to carry the information through information handover. That facility lifecycle information strategy looks, again, not in everything in the dump truck, but it prioritizes the packages based upon utilization. So you look at where the information is created, who has privilege to update it, maintain it, where it's needed, and what the priority. So as a result, it's a no big bang approach to capital project information handover. You look at the current business processes, you look at the information required, and then you carve out the particular source data required and the chain of evidence that carries it from the EPC through to the final operating systems. This bit of requirement has really been addressed in detail by SAP and the SAP team of partners in this space. As you well know, if you're working early enough in the cycle, you're able to influence the specifications with the EPCs. You're able to build a capital project information handover requirement as a part of your EPC contract, and you can carve out a fair amount of detail that you can at least hope that the EPC will adhere to. Quite often it's not the case that those contracts are influenced by the Opex organization, and you get what you get. But in any case, it's a rather inconvenient mix of structured and unstructured information. So in the best case, you're getting hopefully intelligent data in the form of CAD data. You're getting data sheets, you're getting specs, you're getting breakdown structures, you're getting pretty much, well, just a diverse mix of dogs and cats of information that come from the EPCs and then are managed through a transmittal cycle to move into an operating environment. If you look at how that could be done or is done now with customers implementing the best practices, you can deploy an asset information staging area using SAP technologies that we'll talk about in a bit of depth, but certainly not futures. We're talking about capabilities that are available out of the box today, but to develop a staging area that doesn't begin just at the start of commissioning, but begins right after front-end engineering design to take the transmittals, recognizing that there's going to be change, and managing the management of change. So you take a phased progressive handover, each transmittal at a time, and does the management of change to collect, validate, enrich, transform the EAM load data from the earliest possible moments. So as a result, by starting with the long lead time items earliest and then working through the change along the way, you're able to load the EAM system and you get full up EAM operational readiness when you have go live of your new assets. As a result, you're able to run the plant with less specialist labor. You don't have to put the large startup team in place, some, but not as many. You get the operational readiness of the EAM system ramping up quicker. You get increased ramp-up time for production capacity of your facilities, and basically everything that we spoke to as a risk on the last slide becomes a benefit. You get increased production earlier because you're up to production capacity earlier. You got reduced environmental health and safety risk because you've got everything documented in the safety systems, in the maintenance systems. You have proper procedures in place. You don't depend on skilled operators to just know what to do. You reduce the extended startup costs. You improve maintenance productivity because from the first moment you've got accurate, complete information in order to have your maintenance guys working with full knowledge of what work needs to be done. You've got reduced MRO spares costs because you've got proper naming conventions. You know what maintenance needs to be done, therefore you know what spares need to be in place. And you've got lots of other benefits, like with proper documentation, you've got improved warranty management. So by virtue of getting an early start, doing the management of change during the transmittal management phases early in the cycle, you're able to get ahead of the game and get the EAM system validated, loaded, and ready to go when the plant goes live. The SAP team has done quite a bit of work in laying out the activities that occur during the entire Capex to Opex information cycle. I certainly won't walk you through this today, but we'll make these slides, all of these slides, and the recorded version of the presentation available to you so you can dig into this in detail. But several of the SAP industry business units, the oil and gas IBU has led the activity, the chemicals organization, utilities organization have spent a lot of time bringing customers together, bringing the actual owner-operators together to look at the work that happens during that Capex to Opex phase. And they've looked at what technologies can come to bear to improve those activities. We'll focus a bit today specifically on that handover and the work that happens in the information handover phase, recognizing, as we said earlier, that you've got a bit of everything, structured and unstructured information that comes together and is transmitted in each of those transmittals. The SAP team, recognizing this, has built a combination of SAP and SAP partner technologies to build out an asset information staging area. So this staging area is really recognizes that you have a bit of everything coming in a transmittal. You may have engineering drawings, including P&IDs, loop diagrams. You may have 3D models. You'll have data sheets, material safety data sheets, manufacturer's manuals. Some of this information may be intelligent digital data. Some of it may just be scanned PDFs. You got support information like purchase orders, material orders, work breakdown structures. All of this information moves through transmittals from the EPCs, and you'll have numerous EPCs and suppliers through transmittals that might come once every 2 weeks. But this information moves through your transmittal management process into that asset information staging area. Importantly, when it comes to the staging area, we now have a structured environment driven by workflows that are governed by your best practices that can take the structured and unstructured data through a process for validation, transformation, enrichment, approval, and build out load-ready data for your MRO operating environment. The types of data that's built out during that is the structured data required to load SAP plant maintenance, such as equipment masters, material masters, maintenance plans, bills of material, and equally important, we manage the unstructured data, the MRO relevant documents, the transformation artifacts, and an audit trail, such that at the end of the process, you don't just have stuff in SAP, you've got auditable information. So you can touch a pump in plant maintenance and not just see data about the pump, but you've got an audit trail that says, why do you think that's so? That has a workflow. So he says, I have this version of this P&ID, this version of this data sheet as the latest transmittal from my EPC. Based upon that, I applied my best practice validation rules, transformation rules. I have my subject matter experts involved in approval, and I have an auditable process that says, here's the data in maintenance, here are the latest versions of the latest source documents and the transformation rules that have fired. So you have an auditable process that says information in my EAM system is guaranteed right based upon the latest transmittal, and I then have a link between the structured data and unstructured data, so you don't just have a one-time load, but you now have a relationship that can be driven for ongoing management of change. If engineering makes a change to a P&ID, maintenance is notified. If maintenance makes a change that has engineering relevance, engineering is notified. And if you have 3D models coming from your EPCs, tools like SAP's Visual Enterprise is able to interrogate the information from those models and make those models available as maintenance aids as well. So the technologies involved primarily are OpenText, Extended ECM, XECM from OpenText, an SAP partner, MDG for EAM, an SAP Master Data Governance technology, and Visual Enterprise for interrogation of engineering data and development of maintenance aids. So it's very easy for purposes of webinars and PowerPoint to build a simple picture of a process that flows a single time from left to right. But as we well know, these plants change on a daily basis. So once you get the data right through capital project information handover, keeping the data right is equally challenging because plants change every day. They change from break-fix maintenance, they change from shutdowns, turnarounds, outages, they change from brownfield capital projects. So we're really speaking about an environment that will do the work of build out from capital project information handover, but can also be applied in day-to-day management of change activities. Working with the SAP industry business units, the SAP team has built out a number of use cases for this staging area. The one we're talking about today is the large-scale long-term projects. Typical use cases here are capital projects, which is our conversation today. Also, turnaround planning. You know, shutdown, turnaround, outage planning can go on for 6 months or more before you actually do the shutdown. And that long-term planning is quite a bit like a brownfield capital project in that you have thousands of changes underway and you need a staging area that allows you to visualize the to-be environment, build up all of your changes, and then when you have go live again at the end of the shutdown to load all of that resolved information back into your operating systems. So typical use cases, capital projects, turnarounds, mergers and acquisitions when you're bringing large numbers of assets on board. And the characteristics of this staging area are the ones you would imagine. Long duration planning, complex data sets, numerous stakeholders, complex processes. You may even need to do multiple what-if scenarios to say, as I deploy my new assets, I might choose this maintenance strategy or that maintenance strategy. I may inspect more, I may overhaul less. Those what-if analyses are available and necessary in the staging environment. But critically, most importantly, you need an ability to understand where you are in the process. What information have I received from my suppliers, my EPCs? What information is still outstanding? And dashboards that allow you to see where are you in the process of EAM build-out. That information about the staging area and the various use cases is the topic of a broader discussion beyond our scope today, but it also is the same environment that's focused on tactical short-term changes. So one of the scenarios there is once you have that association, those linkages in place, imagine you have a brownfield environment where you've got a maintenance guy that walks out into the plant to perform a maintenance work order and finds that the as-built situation is not what he thought it was. This is not the pump you thought it was, therefore I have the wrong task list, I have the wrong spare parts, you've wasted my time, I've got to go back and start over. He can take his mobile device, same device he's using for his mobile work order execution, and log a change request and say, this is not right, here's the field condition, perhaps take a photo of the brass tag of the equipment or whatever's necessary. documents the fact that the information in the operating system is not correct, and create a change order. That change order then initiates a workflow that's an auditable event. So from that change order, you can do reconciliation of the structured data, of the unstructured data, and most importantly, it bubbles up as an event on the dashboard that says, here was an event where maintenance was ineffective, here's what we've done to fix it, and here's how we reconcile the systems to address that problem. So again, said I wasn't going to talk about that, and I just did anyway. But that staging area is focus of capital projects. It's also the focus of day-to-day. Get it right and keep it right. Let's look at the anatomy of the solution a bit. I spoke about SAP's master data governance is one component of the solution. MDG is SAP's tool for governance of structured asset master data. MDG is actually SAP's enterprise solution for addressing master data. MDG addresses finance vendors, customers, and material master data for some time. Most recently, SAP added MDG for EAM to the price list, which is the focus of the conversation today. But MDG is built directly on SAP's ECC technology stack, so it inherits your data structures, your business rules and requirements immediately upon being installed. It's built upon SAP's ABAP technology, uses the data models, user interfaces, uses the workflow tools, the business rules tools that you have already in your basis organization. MDG has been very well received in the market and does a superb job of managing the structured data portion of our staging area. Here's the architecture that I mentioned earlier. You're using SAP's BRF Plus Business Rules Framework as the business rules engine, the workflow engine that already is used across the board in your SAP basis organization. And EAM is the largest, or is the newest module in the family, along with finance, materials, vendors, customers. This is how we address the structured master data portion of that capital project information handover challenge. Extended ECM from OpenText is the unstructured data portion of that environment. So extended ECM is built with out-of-the-box workflows that address many of the business processes required for capital project information handover, as well as operate and maintain phases of the plant. Extended ECM allows you to build workspaces, and this is what we do in that staging area. As we bring new assets into the environment, we build out the workspaces associated with structured data for new equipment, functional locations, bills of material, and we build out the structured data in MDG. So as we march through that workflow in the staging area, we've got a workspace that contains all of the unstructured content for a new equipment, and we have a change order in MDG to address all of the structured data. So we're able to load SAP at Go Live with the content for plant maintenance, and we load ECM with the documents necessary to ensure that the information stays right. Here's a real simple example of how MDG for EAM and how OpenText work together in that environment. So the process begins with a transmittal. You'll get some body of information from a supplier, from the EPC. Could be P&IDs, could be load sheets, could be data sheets, whatever you get, either in accord with your contract or in the worst case, just what they choose to give you. But that information moves into a transmittal workspace in OpenText. So we move that information into that protected environment that's managed by OpenText. We then interrogate the information that's in that transmittal package, and we create the change orders for the structured data in MDG. So if it's a P&ID that has perhaps 10 tags and requires has 8 maintainable items, we'll create 8 equipment masters and function locations. Now, MDG actually manages 9 objects from work centers to task lists. We have a challenge with PowerPoint real estate, so we'll just talk about functional locations, equipments, and bombs. So we interrogate the information in the transmittal. We create the corresponding structured data in MDG. And then in OpenText, we will build a workspace for every functional location, equipment, material, and we'll move the documents from the transmittal into the individual workspaces. So now, even in the staging area, we've got a one-to-one correlation between structured data for a piece of equipment and unstructured data representing the documents associated with that equipment. We'll carry both of those, the workspace and the change record, through that validation, enrichment, transformation process, such that when you're ready to go live, when we've carried through all the changes of the various transmittals, once we've got accurate, complete asset master data that's managed each of the transmittals through the process, and you're ready to go live, we can load the master data in plant maintenance, and we can load the associated unstructured data, the content in XECM, such that you've got an orderly process. And most importantly, as I keep saying, you've got an audit trail. You don't just have stuff in SAP. You know what's there. You know where it came from. You have the artifacts that are guaranteed latest versions of latest documents, subject matter expert sign-offs. One of our customers has said you've essentially shown me regulatory compliance in a box. So with that, we've covered a lot of material in a short order, but what I hope to do was show you, first of all, the SAP team's understanding of the business problem, and then move from there into a discussion of standards, what people like Epistle and Fiatech have done to make this problem a manageable problem and build methodology and standards that you can adhere to begin to make sense of an environment that might just look like a dump truck handover today. And finally, the technology that is available today, out-of-the-box demonstrable, that allows you to take standards and a documented strategy that you want to implement, and then instantiate that with automation tools that will ensure that your organization behaves in a way that is in keeping with what you really hope to do on your best day. So it's not just a New Year's resolution. It's deployed and enforced and instrumented.
The first question I've received is, how do you ensure that all the information systems required for the run maintenance space are completed prior to startup instead of just thrown over the fence to plant personnel by the project team whose metrics are cost and startup date?
Wow. Well, that was a question by an Opex person, no doubt. That wasn't a Capex guy that asked the question. And frankly, you look right back to the methodology that we started with. If you apply the Fiatech approach, you're designing a pull-based methodology. So you start with those operating systems you're describing. What do those operating systems need to be ready for go-live? And you define the core information and requirements of each of those systems, and then work your way back through the chain of evidence that says, for each of those information elements, what is the source data that drives that information, and then the chain of evidence that says, where does it come from, who owns it, who manages it, and who has the privilege to change it, to view it. And it really is a chain of evidence. But you begin with the source systems and then work your way backwards. So you're not looking at a dump truck. You're not looking at things thrown over the wall, but you're saying, of all the stuff you might throw over the wall, this is the bit I'm waiting for, and I'll look to the metadata of the transmittals and say, I see when you gave it to me, and I have a thread that says when that arrives, here's what's to happen to it. And the automation tools allow that to happen, but again, it's a pull-based methodology. You begin with the end result in mind and then work your way forward. So it's not a question of just chuck it over the wall and hope for the best.
The next question is, how do you recommend project teams, sites, reorganize information from project hierarchy to a run-maintain hierarchy by location?
So it's a great question, and in fact, it's not at all the same. The engineering hierarchy is not a maintenance hierarchy, you know, in many cases, only 10% of the information that's created during the design and construction processes is actually needed during the operate maintain phase. Engineers create a tag for every design element. That's the way they have to do their jobs, but on the operation maintenance side, we only care about maintainable items. So there are some filters that are required just to look at all of the information provided to filter out what you need for operate and maintain. And the target environment is one you've got to think through beforehand. That's actually part of the epistle standard. It says you have to get to the taxonomy requirements for your operate and maintain. ISO 14224 does an excellent example of building out that to-be hierarchy, but defining your operate and maintain hierarchy and then building the mapping that says of all the things you're going to give me, here are the things that matter, and here's how I filter a maintainable item and do the transformation from a engineering tag structure to a maintenance functional location hierarchy. It's non-trivial, but if you know your target environment, you can build the business rules that will make those transformations manageable.
The next question I have is, what can we do if we are too late to influence the information handover specification in the EPC contract?
Also a good question, and frankly, we see that more often than not. The development cycles for new capital projects are, you know, they're 20-year cycles. So quite often, the people that are even anticipating the pain of capital project information handover have gotten there, you know, maybe 10 years too late to really influence the specification of what the EPCs were required to give. So, you know, we quite often see situations where the contract to build a new facility can run to you know, 3,000 pages, and the specification for the information handover can be 3 pages. You can say, I want all the data in digital form, and that's great, except a scanned PDF qualifies as digital. So what we've done in the staging area with the technologies I showed is really anticipate that you can't dictate what you're going to get. You will get dogs and cats. You will get scanned PDF data. And even if the EPCs are prepared to be compliant, quite often they will use smaller suppliers and subcontractors that just don't have the infrastructure to do better than that. So what we've done is built the staging area such that we can bring the best information available into that staging area, and we've got controlled environment. So if the best that you can do is put eyes on a scanned document and do takeoffs necessary to pull out the structured information, it's labor intensive, but you at least have an audit trail. You can say, here's the version of the document, and here is my structured data that was derived from that document, and you have that document under change control. So this raster document, version 7, is the document that I used as the basis for my safety procedures, for my inspection plans, And worst case, it's labor intensive, but you have control. So if you didn't get there early enough to influence the spec, it's just going to be more work. There's no free lunch, but it's manageable. And the infrastructure allows you to get to sound best practice operating environment, even without perfect input data.
What about brownfield capital projects?
That's a special case. That's a very interesting special case. In that your target environment, you're not starting with a blank page. So in a brownfield capital project, you've got existing infrastructure, you've got existing functional locations, equipments, you've got existing warehouses and inventory, and ideally what you want to do is take that capital project information and move it into an existing operating environment. So if you deployed a new pump like the pump you've already got, you want to say, I already have those material masters created and I already have certain spares in inventory. Want to wedge out in your functional location hierarchy and insert the new assets such that they fit in the environment. You don't start with a blank page and you don't start from scratch. So there are particular requirements in that asset information staging area that are required to allow you to make best use of your current infrastructure and quite likely change the tagging, the nomenclature, the descriptions of the information to match the work that you already have. The asset information staging area that you saw there is designed to take that into account, but there's actually new work that's being done by the SAP team now to build a product that will be announced in the fall called EAM Workbench that builds upon the MDG and OpenText technology that you see here and gives you a higher degree of visualization, allows you to do the visualization, even including capabilities with looking at existing hierarchies and infrastructure to do drag and drop capabilities and wedge in new equipments and new systems. So I would encourage you to reach back through your SAP account exec or contact us, and we can tell you what's there today, what's deployable, existing, working today, and also tell you about what's coming with EAM Workbench.
What is the difference between project hierarchy and run maintain hierarchy?
By project hierarchy, what you see in the project hierarchy is the design hierarchy is developed by the EPCs. So an EPC will do a design with tag structures based upon systems and construction standards. Quite often you'll have an order of magnitude more tags, more components in a project hierarchy, and it's built in accord with construction methodology. So it's built with the eye toward how to design it, how to build it in an optimum fashion. So it's a lot more detail, a lot of information that's not necessarily needed in an operate maintain environment. For instance, for a welded pipe in a project hierarchy, every elbow will have a tag because it's a purchased item and has to be tracked down to that level of detail. Now, once you weld them all together, it's no longer an elbow. So in an operate hierarchy, it's a pipe run that will have a functional location, but you're not tracking every elbow. So that's a very simple example. The operate and maintain hierarchy is built upon maintenance methodology and speaking to maintainable items and field replaceable units, and is designed for maintenance optimization and uses the information required for maintenance, including the additional information such as maintenance plans, strategies, task lists, whereas engineering is the detail required for procurement construction and the work breakdown schedules associated with detailed construction. They are related. You can see a crosswalk between the two, but that transformation and filtering is a key component of deploying a accurate maintenance system. There were early efforts, and in some environments it's practical to say every tag equates to a functional location, but often is not. There's a one-to-many relationship between tags and functional locations, and you have to take that into account to build out an optimum maintenance environment.